If you are new to my channel, then please go through the previous videos based on this topic so that you have a better understanding of the concepts which we are going to do today. Exercise 5.2 is based on the formula an is equal to a plus n minus 1d. In continuation with the previous video, I am going to cover up some questions where we will apply the concept of AP to find out the solution of other problems. So let's get started. The first question is, how many two-digit numbers are divisible by 6? Wherever we have to find out number of terms, we can always apply AP to solve such questions. How? First of all, we will form the AP. The smallest two-digit number is 10 and the largest two-digit number is 99. First, we will find the smallest and the largest two-digit numbers which are divisible by 6. Which numbers are divisible by 6? Right, the numbers which come in the table of 6. You can apply the knowledge of tables for small numbers and long division for large numbers. So here we can easily find that 12, 18, 24 are the first few terms. As the terms are separated by a difference of 6, it is an AP and we can easily calculate the values of A and D. Clearly this is a finite AP, so we can calculate the number of terms in it. Let us suppose that the number of terms are n, that means an will be equal to 96. So applying the formula of an and putting the values in it, we get 12 plus n minus 1 into 6 is equal to 96. Solving further by opening the brackets and adding the like terms, we finally get 7n is equal to 96 minus 6, or n is equal to 90 upon 6 equal to 15. So you can see that it becomes so easy to count the numbers by applying the concept of AP. So let us see how we can find the multiples of 4 lying between 10 and 250. Multiple means which is divisible by 4. So this question is similar to the previous question. Let us quickly form the AP. The first number greater than 10 divisible by 4 is 12. Next is 16, then 20 and so on. And the last number is 248, which you can easily calculate by long division. Just divide 250 by 4 and subtract the remainder from it. Let us suppose that this AP has n terms. That means an is equal to 248. Quickly calculate d and then put the values in the formula a plus n minus 1 d is equal to an. Open the brackets. We get 12 plus 4n minus 4 is equal to 248, or 8 plus 4n is equal to 248, or 4n is equal to 248 minus 8 equal to 240. Therefore, n is equal to 240 upon 4 equal to 60. This means there are 60 numbers between 10 and 250 which are divisible by 4. So, I am giving you two similar questions now. Just pause your screen, try them, and then I will discuss the answers. In the first question, we have to find 3-digit numbers divisible by 7. From the table of 7, we easily know that 105 is the smallest number divisible by 7, and the next few numbers can be obtained by adding 7 every time. For the last number, we can take the largest 3-digit number, that is 999. On dividing it by 7, we get remainder 5 subtracted from 999, and the last number is 994. Quickly cross-check your answer and see that have you got the same number of terms. The AP in question 4 is 108, 117, 126, etc. So applying the method and by solving it, we find that there are 100 numbers which are divisible by 9. Wonder how much time it would take if we start counting the numbers? But that's not required because we have the concept of AP. Now let us solve some word problems. In word problems, we will first have to prove that the numbers given in the question are forming an AP. In this question, the annual salary in the first year was rupees 5,000, and then every year an increment of rupees 200 was added. As there is a constant increase, we can conclude that these numbers are forming an AP. and the common difference is 200. Let the salary reach rupees 7,000 in n years. So an is equal to 7,000, or a plus n minus 1d is equal to 7,000. Replace the values of a and d and we get 5,000 plus n minus 1 into 200 is equal to 7,000, or n minus 1 into 200 is equal to 7,000 minus 5,000. Therefore, n minus 1 is equal to 2,000 upon 200 is equal to 10. So n is equal to 11. This means his salary reached rupees 7,000 after 11 years, that is in 2006. In the next situation, we have saving of rupees 5 in the first week, and then it increases by rupees 1.75 every week. In the nth week, the weekly savings become rupees 20.75. Clearly, the savings in consecutive week, that is 5, 6.75, 8, etc., form an AP with common difference of 1.75, and an is given equal to 20.75. Replacing by the formula a plus n minus 1d and putting the values in it, we get 5 plus n minus 1 into 1.75 is equal to 20.75, or n minus 1 into 1.75 is equal to 20.75 minus 5, or n minus 1 is equal to 15.75 upon 1.75. Removing the decimal, cancelling the terms, we get n minus 1 is equal to 9, or n is equal to 10. So savings become 20.75 in 10 weeks. Another question. In this situation, there's a flower bed which has a number of rows. There are 43 rose plants in the first row, 41 in the second, 39 in the third, and so on. And we have to find the total number of rows if 11 rose plants are there in the last row. First, we'll check whether these numbers form an AP. On subtracting consecutive numbers, we see that the difference is coming same, that is minus 2, which implies that 43, 41, 39, etc. are forming an AP. Suppose there are n rows in the flower bed. So an is equal to 11. That means a plus n minus 1d is equal to 11. Putting the values of a and d from above, we get 43 plus n minus 1 into minus 2 is equal to 11. Opening the brackets, 43 minus 2n plus 2 is equal to 11, or 45 is equal to 11 plus 2n, or 45 minus 11 is equal to 2n. So n is equal to 34 upon 2, that is 17. So the number of rows is 17. I hope this answer is clear to everyone. Children, with this we come to the end of this video. I will be back with another video soon in which I will cover up some extra questions based on this topic. Till then, take care and keep practicing.